In this tutorial we are going to create bar bending schedule for slab. So let's get started. Now here is our drawing, and this is basically plan for the slab, and we have schedule over here, we have section over here. Now in section we have reinforcement detail, and this is a pretty straightforward slab, and for beginners it is very important to understand the basic first. Now you can see at the bottom, as I said earlier, bottom are the main bars. Basically we are using 12 mm dia, 200 center to center. Dotted bars are the distributions bar, 10 mm dia, 300 center to center. 150 is the thickness of our slab, and bend we are using here 9D. Let's go into the schedule to check it again. And for main bar, this is only S1, 12 mm dia, 200 center bend or development length is 9D. And for distribution bars, 10 mm, 300 center 9D. Now let's go into the plan and check the placing of our bars. Now here first of all we have red bars, and these are basically the main bars. As I said earlier, the bottom bars are the bars along the width are basically the main bars. So it is mentioned over here that we are using 12 mm dia, 200 center, and length is also mentioned. 77775 is the length. Now next to it, this is basically the placing span right from this position up in here. This is the placing span for this bar, and cutting is basically over here. Next to it we have again the red bar over here, and 12 mm is the dia right from this position up here. The placing span is over here, and this is the cutting span 2225. Next to it we have again the main bar over here. Right from this position up here is the placing span 9725 mm, and this is the cutting span 5750 mm. 12 mm is the dia, 200 center. So this is all about the main bars. We have one another over here right from this position up here 1935, and 2225 is basically the cut length, 12 mm, 200 center. So all of these red bars are basically the main bars. So for the distribution bar, these yellow bars are distribution bars in the longitudinal direction. So we are using first right from this position up till here the placing span 7750 millimeter, and T10 300 center is the distance. Next to it we have one another. It is right from this position up till here 4025 we have this bar, and right from this position up till here 3725 and 3727, that 25 span we have this bar, this one. And next to it we have one another bar, this one, and this is basically the span for this bar 1462.50, and 5075 millimeter is basically the cutting. And the last one over here is basically this one, the yellow one, the last one. It is the cutting span is 1937.50, and placing span is this one 2262.50. So it is very important to understand all of this data over here. What are the main bars and how they are going to placed, what is the cutting span, what is the placing span, everything is very important. So let's start from the main bars. First of all we will find out this bar, and cutting span is mentioned over here, and placing span is this one 6050 millimeter. So main bar, remember the placing span will be in the direction of length, so 6050 is basically the length. It is in between what grid number 1 and 3, so we will mention this as well. Let me move here in this Excel serial number S1, and remember this is S1, remember this one. Next to it we need to put here the length, and length is basically our placing span 6050 mm. So put it over here 6050. There is no need to add the breadth over here because we already know what is our cutting length. Height is 150. And what about the bar particular? So this is main bars between grid 1 and 3, between 1 and 3. It is okay. Next is spacing. So spacing, let me check it, the spacing over here. It is 200 center to center is the spacing. Put it over here 200. Next we need to create a bar shape. So for bar shape is click on this drop down, draw border option, draw border, and we have this one. Next to it, we need to go for the bend directions. We have 290 degrees, so equal to 2 into 2 into dia bar. Next, there is no any other bend over here. Bend or development length equal to, we now is 9 is into d, so equal to 9 into dia bar is over here. And dia bar we are using over here in the main bar is 12 mm. Based on this, you can see the values over here. And a concrete cover in the slab we are using, I think, 15 mm. Now let me check it over here if it is mentioned over here. Now let's check into the journal notes if it is mentioned over here. And a concrete cover in the slab is 15 mm only. What? 15 mm. So put it over here as 15 mm. And then we need to find out the number of bars. So equal to span, this is basically the span divided by spacing is over here, plus 1 will give us number of bars. So 31.25 mean we will round down this one. Round down. What happened? Start the bracket, comma, then close the bracket. Hit enter. Next to it, number of members. So number of members we have only 1, and then total numbers will be equal to number of bars multiplied by number of members. Hit enter. Next to it, what we need to do is we need to find out the total length, and first of all we need to find out this horizontal length. It is mentioned over here. Remember, it is mentioned over here 7775 millimeter. It is easy for us. Equal to 7775, and this is equal to this one, and this is equal to this one. Done from here. Next we need to find out the total length, and it is equal to cut length, this one plus this one plus this one. Next to it, we need to do what? We need to add, no, we need to deduct this bend direction minus this one, multiply it with total numbers, divide it on 1000 in order to convert it into meter. So this is basically the total length over here for 12 mm. Now we need to go for the next main one. Next number 2, this is S1. And what about the length over here? Basically we need to find out the the placing span. It is very important to find out the number of bars. So the next one is in between 3 and 4, this one. So the total length, the placing span is 4875 millimeter. 4875. So let me put it over here, 4875. Next what we need to do is we need to put here the height, and I'll copy this one, paste it over here. Main bar is between 2 and 3, I think. Let me check it again. It is in between 3 and 4, sorry. Right from this position up here. Next what we need to do is we need to put here 200 center. Let's create the shape for this one as well. So for this, I'll unmerge this one, unmerge this one as well. Let me merge right now, right from this position up here. And this is how we can create this one as well. Okay, next to it we have bend direction. So same bend direction will go here as well, because this is main bar. 2 bend directions are over here. Development length are also same, our bend length is also same, it is okay. Dia is also same, concrete cover is same, number of bars, so span divided by spacing. So this is the span, so copy this one and paste it over here simply. Or you can go here and check it whether it is round down or round up. So let me delete all of this stuff from here, round up formula, and check whether we need round up or not. So yes, we need round up, no, round down we need here, round down, yes. So let me undo this one, because we need round down formula over here. Multiply by, we have a number of members as 1, and then total numbers will be equal to number of bars multiplied by number of members. Hit enter. In order to find out total length, first of all we need to find out the cut length, and cut length will be mentioned over here. It is total of 2225 millimeter. 22 equal to 2225 millimeter. What about this one? It is equal to this one, and this is equal to this one. Now in order to find out the total length, copy this formula because it is same as over here. Double click over here, this one plus this one plus this one minus bend deductions, multiply by total numbers divided by 1000, hit enter. So we have find out the main bars here in between 1 and 3 and 3 and 4. This one, it is going to start right from this position up till here. This is placing span, and a cutting span for this bar is right from this position up till here, and it is total of 5750 millimeter. So let's find out this one. Let me go here and I'll copy all of this, or simply I'll go from here, and this is S1, and next to it we need to add here the length as well. So length is basically the span where we need to place this bar. This is the length, 9725 mm. Remember this one, 9725. Next we need to add here the thickness and main bars in between. Let me paste it over here, and then we will do the modification accordingly. And let me simply go here. It is in between 3 and 5. 3 and 5. So 3 and 5, it is okay. 200 center to center. Let's create the shape for this, and this is again the same shape because this is the main bar. So go here, create the shape over here. Next to it we need to go for the bend deductions and the bend or development length. This is main bar, and it is same as we did in the previous one. 12 mm is the dia, 15 is the concrete cover, 25 number of bars. So we need to find out number of bars. Plus 1, this is span divided by spacing is over here, plus 1 will give us the number of bars. 49.62 mean round up this one, round up, start the bracket, comma, we need to close the bracket, hit enter. Next to it we need to give here number of members as 1, and then total numbers will be equal to number of bars multiplied by number of members, hit enter. And now next to it what we need to do is we need to find out the total length, and in order to find out total length, first of all we need to find out the cut length. So let's find out the cut length over here. It is mentioned over here regarding this bar, the total cutting length of this bar is a 5750 mm. 5750 mm, and this is equal to this one, and this is equal to this one. Now next to it we need to go for the total length. In order to find out the total length we will paste it over here, no problem. Double click over here, you can see this one plus this one plus this one minus bend deduction, multiply by total numbers divided by 1000, and this is what we need to find out over here. Now next number 4, and again we will have the main bar. Let me check it over here. The remaining one we have find out till this position. We have this one, and it is in between grid 4 and 5, and this is basically the placing span. 1935 is the placing span. So copy this one, paste it over here. 1935 is the placing span. Remember this one, between 4 and 5. So copy this one, paste it over here. 4 and 5. Next 200. Let's go here, and for this I'll unmerge first all of this stuff from here, and next to it I'll just merge this one as well. Let's go and create the shape over here. So shape is like this. Next to it we need to go for the bend deductions and the development length. This is same, paste it over here. And next dia bar is 12 mm, concrete cover is 15 mm, number of bars, so it is equal to span divided by spacing, span divided by spacing is over here plus 1. Next to it here we have 10.67. so which is the formula? Round up, start the bracket, and then comma, close the bracket, hit enter. Next to it number of members as 1, and then total numbers will be equal to number of bars multiplied by number of members. Next we need to find out the total length, and in order to find out total length, first of all we need to find out the cut length, and the cut length over here is L2225 2225 millimeter. So 22 equal to 22, 25, and this is equal to this one, and this is equal to this one. Now next we need to find out the total length. Copy this one, paste it over here. Simple is this. Double click over here and you can see this one plus this one plus this one minus bend deduction multiplied by total numbers, divide it on 1000 in order to convert it into meter. So we have find out all of the main bars over here. The detail regarding the distribution bar, these yellow bars are basically the distribution bars, and I'll only find out this bar. Now rest like this one, and this one, this will be same as we did here in the main bars, because our span is mentioned over here, cutting span is also mentioned over here. So what else we need? This is straightforward. So I'll find out only one distribution bars over here, this one. Rest you need to find out by yourself. This one, you can see over here the cutting span over here, sorry, the placing span and the cutting span. This one is for this one, this one is for this one. Next we have this one over here and this one. So we have also this one as well. So it is also very easy as we did in the main bar. The same goes for this one as well, no problem. First of all, we will go for this one and the distribution bars, and we will place in this direction. Total span is 7750 millimeter. So I'll simply go here and I'll start right from number 5, slab 1. And what about the placing span? It is important to put here the placing span. So now in the distribution bars, remember one thing, placing span is our width. So put the numbers in the width, 7750 millimeter. So put it over here, 7750, 150. And distribution bars between 1 and 3, I think, in the direction of width. So A and C. You can give the more detail as well in the direction of 1 and 3, 1 and 4, like this. Is A and C. Next to it, what we need to do is we need to put here what the spacing. It is 300 center to center. Next to it, we need to create a shape for this. So as we did in the main bar, the same shape goes here as well. Let's go here to create a shape. Okay, so next to it we need to go for the bend direction. Bend direction is same. We have two 90-degree bends over here, so put it over here. Next we have bend of the development length. 90 we are using over here in the main and the distribution bars. So next to it we need to put here the dia bar. 10 mm is the distribution bars. According to this, you can see the values over here as well. 15 concrete cover, number of bars. So it is equal to span divided by spacing is over here plus 1. Hit enter. 26.83 mean we need 27 bars. Round up, start the bracket, comma, close the bracket. Hit enter. 27 bars multiply by number of members as 1, and then total numbers will be equal to number of bars multiplied by number of members. So this is straightforward to find out all of this stuff over here. It is important to understand the drawing first, and then everything will be easy for you guys. Next we need to find out the total cut length first of all, and cut length is mentioned over here. 60/50 is the cut length, 60/50. And then it is equal to, we have the bend of the development length according to this one as well. And now we need to do what? Let me go here in the format cell to check the alignment. It is okay fast. Next to it, what we need to do is we need to find out the total length, and total length, same formula goes here as well, no problem. Paste it over here. Look, this one plus this one plus this one minus bend deduction multiplied by total numbers divided by 1000. Hit enter. So we have find out main and the distribution bars up till this position. I have find out all of the main bars and now one of the distribution bars. Now it is your duty to find out this one and this one, this one.